All right, good morning. My name is Antonio Fortunato and I'm the Deputy Head of the Crew Operations Unit at the European Astronaut Center in Cologne. Today we will discuss the European experience on the International Space Station. And the presentation will be basically divided in two parts. In the first part, we will discuss what kind of contributions Europe and ESA have given to the ISS program. In the second part, we will see what a typical mission of European astronauts on the ISS actually looks like. So let's spend a few words first about the ISS program. The ISS program is a milestone in the history of human spaceflight. It is an incredible international cooperation, and from a technical standpoint, it is a beautiful, incredible vehicle. It is the biggest man-made object ever put into space, and it has the longest continuous human occupation. In October 2015, we will actually celebrate the 15th year of continuous occupation for the ISS. But what the ISS program actually is giving us, its true legacy, is not really on the technical side, but more on the international cooperation. The relationships that have been built between US, Russia, Europe, Japan, and Canada, and all the other nations that in different capacities have contributed to the program are something that we will be able to use as a baseline, as a stepping stone for all future exploration activities. Also, from a technical standpoint, we will be able to test, and we are testing already right now on the ISS, all those technologies that are actually necessary for longer exploration beyond low Earth orbit. In the picture here, you actually see a very unusual and a unique shot of the ISS. This is actually one of my very favorite pictures, and it is unique in the sense that it is probably the only one in a set that shows the ISS with the ATV and the shuttle docked at the same time to it. And the question would actually be, so where was this picture shot from? The shuttle was attached, and if you look at the Russian part of the station, you also see that there is a Soyuz attached. Well, it turns out that during the mission STS-134, there was the undocking of one of the two Soyuz, and ESA astronaut Paolo Nespoli was actually able to take a shot of the ISS from his departing Soyuz, and this is actually the result of that incredible picture. So what did Europe contribute to the ISS program? Well, the most obvious example is Columbus. Columbus is a module that has been built in Europe and that is actually also operated in Europe at the Columbus Control Center in Munich. You see here in the picture Columbus as it was just attached to the space station in 2008, and you see German astronaut Hans Schlegel actually performing the external outfitting of the module. Columbus is an important part of the ISS. A lot of science is implemented in Columbus, and in a way the module got specialized in human life science experiments. It is considered the human life science laboratory on the ISS. There are incredible facilities in Columbus that enable this kind of research. We have the possibility to take EEG, EKG, we can centrifuge blood, we can do echography, we can measure the weight of astronauts in space, and there is a lot of interesting science that is done thanks to this facility. This is, by the way, how Columbus looks like on the inside. You will notice that there are a lot of bags, and there is a lot going on in Columbus. Now, the other important contribution of Europe to the ISS program is the ATV. ATV has been the first and a very successful attempt of Europe to launch and operate a cargo vehicle. ATV has flown in 5 successful and successive occasions, and has resupplied the ISS with dry cargo, with fluids, but also provided the ISS with a reboost capability. And this reboost capability has been used in multiple occasions, either just to perform a nominal adjustment of the orbit, or to perform what we call a debris avoidance maneuver, when the ISS has to actually maneuver to a different orbit, normally on a higher altitude, to avoid an incoming piece of debris. Now, what is important about the ATV program is what it meant for the ISS so far on one side, but on the other side, it is also what it will mean for future exploration activities. The ATV was very successful, and based on that success, ESA is actually providing now the service module of ATV in a re-engineered and improved fashion for the Orion vehicle. So the Orion vehicle will have a crew module built by Lockheed Martin in the United States, and will have what is now known as the European service module built by Airbus Defence and Space in Europe. One might think, okay, what's the big deal? You had a good vehicle, there was a part of that vehicle that was interesting, that was reused for a successive program. This is a good reuse of hardware, but it is hardly a breakthrough. Well, it is a breakthrough in the sense that this is the first time that actually NASA accepts an important piece of equipment to be provided by Europe. It is the first time that Europe is on the critical path of a NASA development. And we really hope that this experience that we will have with the European service module in Orion will be actually the stepping stone for more and more cooperation and more integration of the activities of the two agencies in the future. Now, Columbus and ATV are the obvious examples of Europe's contributions to the ISS, but there is actually much more. Europe contributed also Node 2. You see in this picture Node 2 as it was attached to the space station in 2007. Node 2 is an important module on one side because it represents the attachment point for Columbus and Kibo, but also because the Nadir and Zenith ports of Node 2 are actually used for the berthing of the HTV, the Japanese cargo vehicle, of Dragon and of Orbital. Also, Node 2 is important because it hosts 4 of the 6 crew quarters. You see here a nice picture shot around Christmas where 3 of the 6 crew members actually just stick out of their crew quarters. The other 2 crew quarters are in the service module on the Russian segment. On top of Node 2, Europe also contributed Node 3. And Node 3 is in a way even more important and even more vital for the working of the ISS. Node 3, first of all, is the gym of the ISS. A lot of exercise equipment is contained in this module. You see in this picture ESA astronaut Luca Parmitano exercising on the T2, which is the US treadmill, but Node 3 also contains the Advanced Resistive Exercise Device, which is actually the machine that one can see in the very background in this picture. And ARED is important because it is the only device on station that can give the opportunity to astronauts to perform weight lifting while in a microgravity environment. Also, Node 3 is important because it hosts a lot of equipment that is part of the regenerative ECLSS. The equipment in Node 3 is able to analyze the atmosphere, it's able to remove carbon dioxide from the atmosphere to provide oxygen, but also what is extremely important for future exploration activities, it is able to take the condensate water and the urine and make it into potable water. As one astronaut very aptly said, the equipment in Node 3, the regenerative ECLSS, actually makes yesterday's coffee into tomorrow's coffee. And by the way, this white block that you see right behind Luca is the US toilet. And it is directly connected to the regenerative eclipse that I just mentioned. Now, one other important function of Node 3 is to actually work as the attachment point for the cupola. Now, cupola is most often known as the best place on the ISS to watch the Earth pass by. Obviously, there are a number of windows on the ISS, but most of them are relatively small, and sometimes they are dedicated to specific equipment. So it is possible to use them to watch the Earth and to take pictures of the Earth, but they are not the most comfortable. Cupola provides a number of windows, a large space, and this is probably one of the most favorite places for astronauts on board. You see here Italian astronaut Samantha Cristoforetti during her mission in 2015 taking pictures of the Earth from the cupola. Now, cupola was not put in space just for Earth observation, was not just put in space for PR reason. It's also there to provide a platform for robotics. Now, before the cupola was actually flown on the space shuttle, all robotics operations on the ISS were performed from the US lab. The US lab was equipped with the robotic workstation, and this robotic workstation provided the astronauts with a number of different views of the robotic arm on the monitors. This was definitely enough to perform operations, but of course, the opportunity of being able to see with your own eyes what the arm is doing while you're operating it is a big step forward, and this is what the cupola is providing. You see here a picture of US astronaut Katie Coleman and Italian astronaut Paolo Nespoli during their mission operating the robotic workstation in the cupola during a nighttime pass of the ISS. Now, we've talked about Columbus, we have talked about ATV, Node 3, Node 2, the cupola. There is another contribution that Europe provided, and it is probably a little bit less obvious, and those are the MPLM, the Multipurpose Logistics Module. While the ISS was assembled, there was obviously a need to bring up equipment, racks, cargo, and to transfer it to the ISS. Now, obviously, because of the way the space shuttle was designed, you couldn't just put the stuff in the cargo bay, because the cargo bay is unpressurized and it is designed to bring up satellites, to bring up modules. So the way hardware was transferred to the ISS was through the MPLMs. The MPLMs were modules built in Europe and filled with cargo and equipment and flown with the space shuttle. Once the shuttle was docked to the ISS, the robotic arm would take the module and transfer it to the ISS itself. Then the hardware would be unpacked and transferred inside the station, and on the way back, the MPLM were filled with garbage or equipment that need to be returned to Earth and then de-berthed and retransferred to the shuttle again. Now, this was done multiple times. It was a very successful contribution, but of course, it could only last up to the time the shuttle was flown. There is no other way to bring the MPLM to space. The MPLM doesn't have its own propulsion system. So we couldn't actually use it anymore after the retirement of the shuttle in 2011 to transfer cargo up and down the ISS. But it would have been a shame not to make a good use of this equipment after the shuttle time. So what was actually done was to take one of the MPLMs and leave it attached to the ISS permanently. This is what is called the PMM, and the PMM actually is nothing else than the closet, than the place where in the ISS we put cargo and material. You see here US astronaut Katie Coleman posing together with the 3 of the spacewalk suits available on the ISS. And it cannot be understated how important it was for the program and for the operations of the program to have this closet available. The ISS is a huge vehicle. There is a lot of space available, but because of the number of activities that are done on the ISS, there is also a lot of equipment going around. And to have a place where you actually don't have hardware that you need to access, but just space that you can fill with cargo is of extreme importance for the operations.